Okay, so the last big unit that we're going to be working on in the course is this idea of hypothesis testing. And before we start giving any definitions or anything formal with respect to hypothesis testing, I want to give you an example of what a hypothesis test is just in real life. One of the statistics that we've been throwing around in class is that approximately 6% of all people have O-negative blood. So the probability that somebody has O-negative blood is 6%. Now, what if we lined up 100 people? And let's say that we wanted to determine whether that claim is true or false. So this is a claim about a population. So what if we surveyed 100 people to try to determine if this is going to be valid or invalid? So let's say we surveyed 100 people. And let's say that there was nothing else other than the fact that we could get their blood type. Maybe we had a machine that was able to garner their blood type so that they couldn't lie. And we just surveyed those 100 people. Now, I have a random number generator. And what I'm going to do is I'm going to randomly generate numbers. And if the number comes up as either 1, 2, 3, 4, 5, or 6, 6 out of 100, then I'm going to designate that that's a person with O-negative blood, and that's a success. So give me 1 second. So I'm randomly generating this, and I'm just going to read this off really quickly. So I have one person with O-negative blood, and then I'm looking down my list, and I have 2, 3 people. All right, I'm still looking down my list. Here's a 4th. So I have 4 people in my list. All right, so I surveyed 100 people, and only 4% out of 100 have O-negative blood. So, now, why does this happen? Well, that's because we don't have the population. So we only have a subset. And a subset of the population says that we only have 4%. So the question is 4% a big enough disparity between 6% to say that it's not due to random occurrence? Okay, so we always have to factor in the idea of random deviation from 6%. Okay, and the question is a 2% deviation significant? So that's the question that we're trying to answer. All right. If I did this test again, I might get something different. And in fact, let me do it again just so that way we can see what would happen. So in one study, we got 4%. Okay, so is a 2% disparity significantly different? All right, so let me run this again, and we'll see what happens. So we survey another 100 people. All right, and if we survey another 100 people, I'm just going to count down the list. So I have 1, 2. So this time only have 2 people out of 100. Okay, so 2% have O-negative. All right, so again, is the disparity big enough? And that's the question that we're trying to answer. All right, so that's what hypothesis testing is. We have something that we know about the population. So we have a claim, 6% of all people have O-negative blood. Then we come up with this idea of an alternative hypothesis, and we took 2 samples. So we have a 4% and we have a 2%. From these 2 samples, it might suggest that the actual proportion of people that have O-negative blood is less than 6% from those 2 samples. However, another sample might suggest that it's greater than. All in all, we're trying to look to see if the disparity is significant, okay? And the most important word that we're looking for is significant. In other words, what's the probability that this is due to random chance? And we're going to be talking about that as we go along. So I want you to stop the video. Well, I'm going to stop the video and just think about this and maybe try to apply it to something in real life. And then we're going to go through some formal definitions, and I'm going to use this as a basis for the definitions that we're going to go through.